All right, so here is example 2 from Special Cases of Factoring. I still see a squared term, so I'm going to be one of the squared cases. Now, this is the one that I was talking about in the last video, that you don't really have to memorize these formulas. They will provide you with shortcuts. However, these things factor like normal. You may notice when you're doing your homework, when you factor some of these, the numbers get really big. That is the benefit to the formula. But these factor like normal. So going back to several videos ago where we were factoring with a greater than 1. So I've got 9 times 1. It's going to give me 9. Well, my factors of 9 are 1 and 9, 3 and 3. Well, the two of those that add to 6, of course, would be 3 and 3. So I'm going to split up that 6x and write it as 3x plus 3x. Because all those signs are positive, of course, the 3x's will be positive. I'm going to carry everything down. Factor by grouping. So I've got 3x in the first one, which will leave me with 3x plus 1. Carry down my sign. Those 3x and 1 have nothing in common, so I write that as plus 1. And then I'm left with 3x plus 1. Write down what is being repeated. Write down what's being repeated. 3x plus 1. And then what's left over. 3x plus 1. And of course I could write that as 3x plus 1 squared. That is the special case. The special case just says that it is going to be the same factor written twice. Either one of these would be accepted. I would prefer you get in the habit of writing it as 3x plus 1 squared, because where you're going in Math 102 and Math 110, that's going to be the form that we work with. My last example, notice that the degrees on these now have changed. The degrees have turned into cubes. So I am going to use my perfect cube or difference of cubes, sum or difference of cube formula. For this one, I'm going to use the sum because, as you can tell, it's an addition sign. So I'm going to use that thing right here. Of course, on the second one, because it's a subtraction, I'm going to use the difference. And let's draw a line to separate these two. And truly, it just turns really into figuring out what x and a are in the formula and then filling it in. So for this one, y is already written as something cubed, so I'm going to keep that as y cubed. 64 is the same thing as 4 cubed. So what that tells me is here, where there's an a, I'm going to replace this thing with a 4. Where there is an x, I'm going to replace with a y. So I'm just going to fill that thing in. So I've got x plus a, well in my specific example is going to be y plus 4, x squared, which in my example is y squared, minus a, 4 times x, but it's y, my variable is y, plus a squared, which is 4 squared. So then I'm just going to go through and simplify. Y plus 4, y squared. Well, 4 times y is just 4y, and then 4 squared is going to give me 16. So that would be my final answer. In the second one, this one's a little bit more challenging because I have a GCF first. So 3 and 81 actually have a 3 in common. So before I do anything, I want to take out a GCF of 3. So I'll have 3. When I divide that thing out, I'll have y cubed minus 27 x cubed. Now I need to rewrite this to match my formula. So of course y cubed is going to stay. 27, though, I can write as 3 cubed and then my x cubed. So I'm going to, if you remember back to chapter 5 where we had our exponent properties, I can write this as 3x with a cubed all the way out. I can kind of take that cube and move it outside. Now, this is what's going to be acting as x. This is what's going to be acting as a. So I'm going to fill in my formula, and I'm going to rewrite it just so that we can follow along as to what we're filling in. I'm going to rewrite this thing with a y everywhere I see an x, and then a 3x everywhere I see an a. Now I'm going to go through and finish out my formula. Now this thing I can now simplify. So the first part will stay the same, y minus 3x, y plus, well, 3x times y is just going to be 3xy. And then this last one I have, that's really the same thing as 3x times 3x. So that's going to give me 9x squared. And that would actually be your final answer.